Okay, in our little voyage of discovery about dot products, the next thing we'll note is Theorem 1 in the box in section 10.3, and that's to say the angle between two vectors, let's have our u and v again, is simply given by theta, this angle here, is equal to arc cosine of the dot product of u dot v, okay, divided by the magnitude of u and the magnitude times the magnitude of v. Okay, so you can think of that, you could think of this, we could put this in the numerator, but it's just more convenient to write u dot v and in the magnitudes of those vectors, and this theta then is equal to the arc cosine of this amount, which of course means that the cosine of theta is equal to u dot v over u v, the magnitudes of u and v multiplied by each other. So already we see here, by using the dot product method, we can calculate the cosine of theta. Now this shouldn't be overwhelmingly surprising. I mean, it's not, we normally use a calculator to find this, but if we have a rectangle where, this is 5 and this is, I don't know, 3 or something like that, and this is 4, whatever it would be, we can just look at that, and based on these sides, we can find out that in this case the cosine of theta, which we may not know what theta is right off, is equal to 4/5. Okay, so we can mechanically calculate that by having the triangle. Basically what we're doing over here, and this is actually proved in your book on page 629, is starting out with the law of cosines and basically using trigonometry to demonstrate that this statement is true. Once we know this statement is true, we know what's inside here is cosine theta. We simply take the inverse of that and we're going to pop out with our theta. So you really need to memorize this and this because they're very practical things to know.